Today's Daily Dose of Math is about finding the y-intercept and finding the zero for a straight line equation. Now, there are actually two very good reasons to be able to do this. Often, the question you're asked in itself wants the y-intercept or the zero. You want to be able to produce them. But also, knowing the y-intercept and knowing the zero is the most efficient way to graph the straight line equation. And very often you need to do that too. Here we have two straight line equations, equation 1 and equation 2. Equation 1 is in y equals ax plus b form, which is one of the standard forms for the equation of a straight line. And equation 2 is in the ax plus by plus c equals 0 form, which is another standard form for the equation. We're going to start with equation 1 and see that the y equals ax plus b form is extremely useful for finding the y-intercept because the b in that form is the y-intercept. Therefore, since this equation is already written in that form, I can see that my b is 6. And I have found the y-intercept just like that. Very useful. But to find the zero for equation 1, there's a little bit more work involved. Now, the zero is similar to the y-intercept. The y-intercept is the point where the line crosses the y-axis. The zero is the point where the line crosses the x-axis. And we can't just look at the equation and see the zero the way we could with the y-intercept, but we can do a simple bit of algebra to find it. We take our equation and we make y equal to 0. Because the point that crosses the x-axis will always have to have a y-coordinate of 0. And then we do algebra to isolate our x. We have found our 0. If I move the 3x to the other side of the equals, it becomes negative. And if I divide both sides of the equation by -3 in order to isolate my variable x, I get x equals -2. And I have found my 0 for equation 1. Now let's look at equation 2. We can't just look at this and know either the y-intercept or the 0. And there are actually two different methods that I'm going to show you that allow us to find the y-intercept and the 0 for equation 2. The first method is use algebra to get the equation into y equals ax plus b form. So I'll start with that. So the first thing I did was keep the -4y on the left of the equal sign and move both of the other terms to the other side where they changed signs. And now I'm dividing everything in the equation by -4, which allows me to cancel. I have y equals 1/2 x plus 2. And I can see that my y-intercept is 2. And now I'm going to find the 0. I'm going to use this y equals ax plus b form, and I'm going to do it the same way I did here. I make y equal to 0, and then I isolate my x. I'm cancelling the numerical coefficient of x, and x equals 2 divided by -1/2, which is -4. I have my 0 for the second equation. So there was a bit of algebra involved, both at the beginning and in the finding of the 0, but I'm able to do it, and I'm using y equals ax plus b form to do it. Now I'm going to erase, and I'm going to do example 2 again, but I'm going to use a slightly different approach to the algebra. So just bear with me while I erase. Okay, while I wait for the chalkboard to finish drying, I'll find the 0 for equation 2 on my whiteboard. And what I'm doing is I'm not converting it into y equals ax plus b form. I'm keeping it in the form that it's already in. But I'm using the same logic, which is that I know that the 0 is the x-intercept, and that's the point where the y-coordinate is equal to 0. So I replace my y with a 0. This cancels, and I have 2x plus 8 equals 0. 2x is therefore equal to negative 8. Divide both sides by 2, and I have x equals negative 4, which is the same answer that I had with the other method. And this still isn't very dry, but I'm just going to write over the wet part because I'm tired of waiting. To find the y-intercept, when I don't have it in y equals ax plus b form, I'm using a very similar trick. But I'm not going to make the y-coordinate equal to 0, the y, I'm going to make the x equal to 0. So I started with 2x minus 4y plus 8 equals 0, and I replaced the x with the 0. And this cancels. I have negative 4y plus 8 equals 0, but I'll move the 8 to the other side where it'll become negative. And I'll divide both sides by negative 4 in order to isolate my y. I cancel, and I get positive 2, which is the same answer that I had using the other y equals ax plus b method. Now, this method might seem a little bit slower, and it's really up to the student to decide which method they like better and use that, because if you feel more comfortable with the method you're using, you're probably going to make less mistakes. That is how to find the y-intercept and the 0 for a straight line equation, regardless of which form the equation is given to you in. And that is today's Daily Dose of Math. Please like, subscribe, and share.